Welcome to Unit 4, Lesson 16, Solving Quadratics. Let's solve quadratic equations. Let's remember our Algebra 1. Okay, so today we're going to be looking at a perfect square trinomial where if you have a binomial, a plus b squared is the same as a squared plus 2ab plus b squared. Okay, here goes some more notes with examples. Okay. Find the perfect squares. I don't know if this is a perfect square. So the first thing I'm going to do is if I take the square root of 25, I will get 5. And I know that 2 times 5 equals 10 using the formula from before. So this looks like a perfect square trinomial where x plus 5 quantity squared is the answer. How do I know x plus 5? Because this is x plus 5 times x plus 5. And all I have to do is multiply x times x, gives me x squared. If I do 2 times the a term times the b term times 5 squared, I get x squared plus 10x plus 25. Now for the next one. If I take the square root of 29, that is not a perfect number. This is not a perfect square. If I take the square root of 8, it's not a perfect number. This is not a perfect square. But if I take the square root of 9, I get 3. If I times it by 2, I get 6. So now we match, but now I have to pay attention to this. This is going to give me x minus 3 quantity squared. And how do I know? X minus 3, x minus 3, x squared minus 2 times x times negative 3 plus 2 plus 3 squared. It's plus 2 times a times b. Your b happens to be negative 3. X squared minus 6x plus 9. Okay, let's look at this problem. Here, this is the first steps of completing the square. So when we complete the square, what we have to do is take the b term. Remember, in a quadratic equation, you have ax squared plus bx plus c, which must be equal to 0. Okay, whereas a, b, and c are all real numbers. All right, so a, if there's no number written in front of a, the number is 1. Okay, so now when we complete the square, the formula is negative b divided by 2, then square it. And so you get negative b squared over 4, whichever it is. Okay? So now, we take our negative 6. We divide it by 2. We get negative 3. Then we square it, and we get 9. So the reason 9 will make this, so what Elena did was add 2 to both sides to make this a perfect square trinomial, because this becomes x squared minus 6x plus 9 equal to 2. And then when you factor it, you get x minus 3 from the previous page. Okay, so when you take the square root of both sides, 2 goes under the radical. And when you take the square root of a positive number, you get a positive and a negative root. So this plus minus means positive and negative. And so this is how Elena solved the problem. Okay, so we're going to solve these probably a couple at a time. I'm probably had to put these on a couple different pages. Okay, so solving the first one, x squared is equal to a positive number. Take the square root of both sides. X is equal to positive 10 and negative 10. Okay, for the next one. Take the square root of both sides. X is equal to root 38, positive root 38, and negative root 38. The root of a non-perfect number is exact. This is an exact number. Please do not turn these into decimals. That makes the numbers inexact because you're rounding and rounding errors occur. So please don't do that. Okay, for the next one. 25, the square root of 25 is 5. 2 times 5 is 10. And the reason why I have to do this is because the general formula for a perfect square is x squared plus 2 times a times b plus b squared. So I multiply the square root of the third term by 2 to match the middle. And because this is negative, I got x minus 5 quantity squared equal to 0. I take the square root of both sides. I get x minus 5 is equal to 0. And then adding 5 to both sides gives me x equal to 5. And I'll do the next one on the next page. Okay, 4. Can I find factors of 40 that add to 14? So let's see. First thing I'm going to do is I'm going to list all the factors of 40. 2 and 20, 4 and 10, 5 and 8. And I don't think I get anything else. 6, 7, 8, 9, 10 repeats. I don't think I get anything else. The next thing I do is I add them. I subtract them. This takes a long time, but this is a surefire method of finding the proper answer. I see 14 is the same as the middle term. That means 4 and 10 are my factor pairs. So I got x and 4 and x and 10. Since the sign here is positive and this side here is positive, they're both positive, equal to 0. X plus 4 equal to 0. X plus 10 equal to 0. Subtract 4 from both sides. Subtract 10 from both sides. X equals negative 4. X equals negative 10. So we should always get two solutions unless it's equal to 0 or a negative number. Okay, looking at the next one, we get 39. 39 is not a perfect square. What are the factors of 39? Let's see if we can simply do this. 1 and 39 and 3 and 13. There are no other factors. So 40, 16, subtracting, I get 38 and 10. Neither one of those matches 14. So this is not easily factorable. So what I'm going to do is I'm going to separate. I'm going to put the plus 39 equal to 0 way over here. I'm going to take the 14. I'm going to divide it by 2. I'm going to get 7. Then I'm going to square the 7. So you do b over 2. And then whatever that is, you square it. And that gives me 49. So if I add 49, I have to add 49 to both sides. Because what you do to one side of the equation, you had to do to the other. So this is completing the square. Because this becomes x plus 7, quantity squared. If I subtract 39 on both sides, I get that equal to 10. I take the square root. I get x plus 7 is equal to the positive root 10. And I get x plus 7 equal to negative root 10. I subtract 7 on both sides. And x is equal to negative 7 plus root 10. And x is equal to negative 7 minus root 10. 10 is a positive number. And because when x squared is equal to a positive number, you get two roots. You should get two roots. And these are real numbers. They're just irrational. Okay, finally, for the last one. 3x squared minus 5x minus 11. There are no factors of 11. This one is hard. I am going to hold off on this one until Monday, until we get into the quadratic formula. So I'm not going to do this one right now. Because of that leading 3, I'm not going to touch that right now.